My name is Sean Wojtowicz, and this is the 2004 number 3 Calc BC FRQ. Here's the given information in the problem. An object is moving with position x of t, y of t, at time t is greater than or equal to 0, and dx dt is equal to 3 plus cosine t squared, and at t equals 2, the position of the vector is 1/8. Here is all the information and work for part A of the problem. So part A asks you to find the x-coordinate of the position of the object at time t equals 4. So when I first saw this, I didn't realize that this was a calculator problem, and I started working it out by taking the integral of 3 plus cosine t squared, and I got all this crazy stuff with the value of c, but I realized that I was going about it the wrong way, and there's actually a much easier way to do it. So what you do to find the x value at t equals 4 is you take the value at t equals 2, and then you add it to the change in x between 2 and 4, which is just the integral from 2 to 4 of x prime of t, which is given. That's the 3 plus cosine t squared. And so what you get from that is x of 4 equals 1, the value of x at 2, plus the integral from 2 to 4 of 3 plus cosine t squared, and then you can plug that into your graphing calculator. And if you have a TI-89, the way that you're going to plug that in is 1 plus f3, and then hit the number 2, and then it'll pull up an open parenthesis and an integral, and you type in 3 plus cosine parentheses x squared, comma x, comma 2, comma 4, closed parentheses, and then you just hit enter, and it should spit out something around 7.133. And what you're going to get points for in this problem is having the value of x of 2, which is 1, and then having that integral from 2 to 4 of 3 plus cosine t squared, and then having the answer. Here's all the work and information for part B of the problem. So part B states that at time t equals 2, the derivative of the y part of the function is -7, and then it asks you to find the equation of the tangent line at the point x of 2, y of 2. So we know that the slope of a vector function is going to be the derivative of the xy function, which is dy over dx at t equals 2 in this case, which is also dy over dt over dx over dt. So that's y prime over x prime. So y prime in this case is -7 because that's given in part B, and x prime is going to be that 3 plus cosine t squared, which in this case is 3 plus cosine 2 squared, or 3 plus cosine of 4. So when we put -7 over 3 plus cosine of 4 and plug that into our calculators real fast, it spits out something around -2.893, and that's going to be the slope of the tangent line at the point x of 2, y of 2. And then we know from the problem's given information that x of 2 is 1 and y of 2 is 8, because it states that at time t equals 2, the position is 1/8. So then we make use of point-slope form to find that y minus 8 equals -2.893 times quantity x minus 1. And this part of the problem is worth 2 points, and the two things you're going to get points for are a correct value of the slope of the tangent line and the answer, the equation of the tangent line. Here's all the information and work for part C of the problem. So part C asks you to find the speed of the object at time t equals 2. And it may be confusing because some people mix up speed and velocity, which in this case in Calc BC are very different, but the equation for speed is the square root of dx squared plus dy squared. And so the derivative of x at 2 we know is going to be 3 plus cosine of 2 squared, because dx is 3 plus cosine t squared. And so 3 plus cosine 2 squared can also be written as 3 plus cosine of 4, which when you plug it into your calculator gives you 2.346. And then we know from part B of the problem that the derivative of y at 2 is going to be -7. And so when you plug those two numbers in, you get the square root of 2.346 squared plus -7 squared, which is going to give you 7.382. And the only thing you're going to get points for in this part of the problem is the answer, because it's pretty straightforward and doesn't take that much time to solve. Here's all the information and part of the work for part D of the problem. So for part D, I decided to split it up into x double prime and y double prime, because those are the two parts of the acceleration vector that it asks for. So part D states that for t is greater than or equal to 3, the tangent line of the object has slope 2t plus 1. Find the acceleration vector at time t equals 4. So obviously y double prime is going to be the derivative of y prime, but we're not explicitly given y prime. In fact, in the problem it states dy over dt is not explicitly given. So what we can do is we can play around with what we have to make up y prime. So if we do dy over dx times dx over dt, the dx's in the denominator and numerator will cancel, and we just use two expressions we already know to get y prime. So that's going to give us 2t plus 1 times 3 plus cosine t squared, which when expanded out is 6t plus 2t cosine t squared plus 3 plus cosine t squared. That's your y prime. And now obviously y double prime, you're just going to take the derivative of that with respect to t. So then you get 6 plus 2 cosine t squared minus 4t squared sine 2t minus 2t sine t squared. That's your second derivative of y. And so for a TI-89, what you want to do is you want to write out this whole function in your calculator, and then you put the such as bar, which is on the left-hand side of the calculator, and then you type t equals 4, then you just hit enter, and it's going to spit out something about 24.814. So once again, here's the information for part D, but the other part, the x double prime. So x double prime is obviously going to be the derivative of x prime, which luckily we're given in the problem as 3 plus cosine of t squared. So the derivative of that with respect to t is simply going to be negative 2t sine of t squared. And so what you want to do on your graphing calculator here is you want to type in this negative 2t sine of t squared, and then you're going to hit the such as bar, which you used for the last problem, and then you're going to type in t equals 4, and then you hit enter, and that's going to spit out something about 2.303. So now you have your x double prime and your y double prime, so you can write your acceleration vector, which is 2.303, comma 24.814. What you're going to get points for in this problem is going to be the value of x double prime, the 2.303, the written out version of y double prime, and then you're also going to get points for just having the acceleration vector. So basically for each part of this entire FRQ, you're just going to get at least 1 point for having the answer in each thing, and then you're going to get 1 or 2 extra points based on having the numbers throughout your works, in this case, the x double prime and the y double prime. Thank you for watching, and I hope this helped you figure out how to solve this problem. And as always, Mr. Farrar, if you're rewatching this video for my letter of recommendation, please assume that I was your favorite student.